Good morning, everybody. We are going to continue our work in number theory. I wanted to start with a quick review of set, union, and intersection. That's an operation you learned last year. It's an idea about how we relate sets. We'll recall for a moment that union can be most easily thought of as quite simply something that is either in one set or the other. So think of it as an or question, whereas intersection is and. So let's write this down here. I'll say intersection is and, think of union as or. So given those two sets, if I ask you what is the union of A and B, we're just identifying any elements that are in set A or set B. So that's pretty simple. 1, 2, 3, 4, 5, 6, 8. Just separate them with commas, have them in braces. Order doesn't really truly matter there. Intersection, on the other hand, is a much more limited set because I'm only looking for those things that happen to be in both, and that's going to be 2 and 4. For A minus B, now order matters here when you're talking about set difference. We're in this case, we're starting with set A, which is 1, 2, 3, 4, and 5. However, we're now going to remove from A any elements that are in B. Do you see what that's going to be? Yeah, it's going to be a set of 1, 3, and 5 is what's left because, again, as I said, it's removal of elements from set B. So 2's in set B, 4's in set B, so I remove those. 6 and 8 aren't present, so I'm not even going to concern myself with them. B minus A, on the other hand, means you're starting with 2, 4, 6, and 8, and now removing those elements that are in A from it. And as we can see, there's pretty clearly a 2 in set A, and there's a 4 in set A, and that just leaves me with a set of 6 and 8. Okay, now just to quickly additionally review sets and subsets, when we're writing these questions here, it's important we understand the difference between these two symbols. This means is an element of. You should know that by now, of course, but just in case. And this is a subset of. Okay, so in this case, I'm going to say true. Remember, in this, by the way, remember we looked at this. This is the box man talk, right? Remember box man? He had a box, and he's looking in. And if it's an element of, when it's an element of, he's just looking into the box, and does he see a 2 or 3, or 4 or 5? There's 2, 3, 4, and 5 in the box. Does he see a 3 in there? Yes, he does. 3's floating around in there. Do not confuse our element guy with subset guy, because subset guy over here, he has another box to fill. And he's got these long arms, and he's going to start reaching in there. Now, in this particular case, again, he's still looking in this box. There's a 2, there's a 3, there's a 4, there's a 5 in here. Can he reach in and pull out a 3 and box up a 3? Well, that's the problem. I'm going to call this false because there's a 3 that's in here, but it's not a set, whereas this one is true. See the difference here? Wait. I messed that up. This one's false. This one's true. That's what I thought I was about to read. There we go. Helps if I actually read the question here. Yeah, because again, let me say it again. This one's false because this is asking, 3 is a subset of. Now this over here, as I said, that subset guy, he's trying to create a new set. The box is kind of like the set braces, if you will. So on this next one, I was anticipating this was saying set of 3 is a subset of, and it's not. Now, the braces around it are basically saying, is there a set of 3 inside of here? No, there's just a 3 alone. I would have said true, by the way. This could have been true if I had braces around the 3. Now it's a true statement, but that wasn't what was given to me, so I'm not going to say true. I'm going to say false. However, on the end, this one here, this is true. It's saying the set of 3 is a subset of. Yes, because he can reach in, grab that 3 with those mitts, and drop it in over here, and voila, he's got a set of 3 now, if he pulls it out of there. Okay, so if I give you a set and call this, set A, the set of 3, and then with the set of 4, then I got a 5, and then I got a set with 6 and 7 in there. This is one of those things where it does confuse people, because if I ask you how many elements are in set A, you would actually say there are 4. This is an element, that's an element, that's an element, and this box is its element. Again, if we looked at it as, Boxman would, right now we've got a 3 and a 5 floating free in here. We have a box with a 4 in it, and then I got another box over here in the corner that's got a 6 and a 7 in it. 1, 2, 3, 4. See? All right, so is 3 an element of A? Yes, it is. That is a true statement. Is the set of 4 an element of A? That's also true. I've got 4 in there and it's in a box. 5 is not in a box, so I'm going to say it's false. Is a set of 5? No. I've got a 5 floating free, but not a set of 5. Is the empty set an element of A? No, there's no empty box in there, so I'm going to say false. I could create an empty box, though. That's the one that always confuses people, but this one is definitely true. The empty set is a subset of our collection of elements of A. That is to say, if Boxman, he could walk away with an empty box, so that's definitely a possibility. The set of 4 is not a subset of A because it's already in a box. Now, change this around, to if I say the set of 4 is a subset of A. Now that's going to be true. And finally, the set of the set of 3. Again, 3 was a free element inside of here, so I'm just going to call this one, I'm going to call this false as well. Now, again, if I actually have the ability to, if I have that ability to, box up the 3, if this 3 were, boxed up here, if I had that going on, now it would have been true. So I could pull it out. I could pull it out and put it in yet another box over here, and have a set of the set of 3. Then it would have been true. But as written, nope, none of that stuff's going on. So we're going to leave it as false. Hope that helps. Now, finally, identify the number of divisors of 140. You should write this down somewhere. 140, you want to write this as a prime factorization. Of course, I like to use the chimneys, as I said yesterday, if you were part of my class yesterday, so that's 5 and 7. So this is going to be 2 squared times 5 to the first times 7 to the first. Don't really need to write that 1 in there, but I like to because I want to make it clear that there are 3 ways I could write the power of 2 to the first, to the second, or to the 0th. 2 ways for this times 2 ways for this, and recall from probability when we're counting events, 3 times 2 times 2, this is going to be 12. There's 12 arrangements I can make with those exponents for those factors of 2, 5, and 7. So 1,250 on the other hand, let's see, going to be bigger, right? Well, let's see. I look at this, I know it's even, so I divide it by 2, I get 625. It's not even anymore, but I can see it divides by 5 pretty clearly. So that makes 125. I divide this by 5, and I get 25. Divide that by 5, and I get 5. Aha. So this is going to be 2 to the first times 5 to the 4th power. Now, using the same principles I had above, that is, count the number of ways, including the power of 0. 2 ways I could write this, times 5 ways I could write this exponent, leaves me with 2 times 5 is 10 divisors of 1,250. Okay? So, I want you to complete through exercise 31 on page 14. Not a terribly lengthy assignment today, it's just 3 exercises, but you'll see 29 is rather involved, but it's 40 points. Those are 40 relatively easy points, though, if you're following the directions. There's a couple of exemplars in that problem, so it should go pretty easily for you. Make sure you smash that like button and subscribe to my YouTube channel. Be good for your parents. Have a great day, everyone.